Hi, hello, welcome to the channel. Today we are going to see the centroid of an unequal angle section. How to determine the centroid of an unequal angle section 100 mm by 80 mm by 20 mm. Angle section. So this is an angle section, okay, unequal. So this flange and this web are of unequal length. See, this is 80 mm while this is 100 mm. If both are equal, that is 80 and 80, it is equal angle section. But over here, it is unequal angle section. That is 80 mm is the flange and 100 mm is the web. Okay. So, the flange section I have taken it as 1. Okay. So, I am dividing this into regular surface. So, I get two rectangular surfaces. So, I am dividing it in this part. Okay, over here I have divided it. So, the flange dimension is breadth. This is the breadth 80 mm. This is the breadth. And the depth is 20 mm. Okay. And finding out the area, A1 is B1 into D1. That is equal to 80 into 20 as 1600 mm squared. Okay, this is the area. And coming to the web section, this is the web section. So that is also, okay, breadth is 20 mm. This is the breadth, okay, and the depth is 80 mm. See, only this is the depth, okay, so this will be 80. Totally it is 100. 100 minus 20, you get 80. Okay, so the area again is B2 into D2. That's you're getting 20 into 80. That is 1600 mm square. So you have got A1 1600 mm square, A2 1600 mm square. And coming to x1, y1, we have to locate the centroid of this flange section. So this G1, and this is a second. There is a web section. The centroid is G2. Okay, and x1 value. Okay, the distance from the reference axis. So this is the reference axis. 0x 0y in the green color. No, that is the reference axis. We have seen in the last class itself. So the distance from here to this point is half of 80. Okay, so this is 40. So 40 mm. And y1 from this 0x, the height up to this point, that is, okay, 10 mm. 10 mm. Whereas coming to the web section, x2, this is a center point, centroid of this rectangle. So x2 is the distance of this centroid from the reference axis. So from here to here is 10 mm. That is half of 20. And y2, the distance from this OX reference axis to this centroid. So you see, this is 80 and half of that is 40. So this is 40. Okay. And this is 20. So 40 plus 20. So 40 plus 20, you get 60 mm. Now we know a1, a2, x1, x2, y1, y2. We can directly apply in the formula. X bar is equal to x1 a1 plus x2 a2 divided by a1 plus a2. That's equal to x1 you have 40 into a1 is 1600 plus this x2 is 10 into 1600 divided by 1600 plus 1600. That's equal to so it is 64,000 plus 16,000, you get 80,000 divided by 3,200, that is 25 mm. Whereas y bar is equal to y1 a1 plus y2 a2 divided by a1 plus a2. So y1 you have, that is y1 is 10 mm, so 10 into 1600 plus y2 is 60 into 1600 divided by 1600 plus 1600, that is equal to, so you get 16,000 plus 96,000 divided by 3,200, that is 1,12,000 divided by 3,200, you get 35 is the answer. So x bar is 25 mm and y bar is 35 mm. So the centroidal axis, you can draw it. So the centroidal axis, that is xx and yy, x bar is 25 mm from the reference axis, so this is 25 mm, and y bar, this is x bar, and this distance is y bar is equal to 35 mm. So you can draw this xx and yy from 25 mm from the reference axis and 35 mm from this reference OX axis. Okay, so this is the center point, that is the centroid of this L angle section, unequal angle section. So G, this is the centroid. Okay, thank you for watching. If you have any doubts, you can contact me. You can share your views in the comment box. Thank you.